There is one topic in the third module, that is balanced search tree, under which this AVL tree is asked. Okay, so this AVL tree, I have written the definition over here. AVL tree is nothing but BSC, that is nothing but a binary search tree in which the balance factor of every node, which is defined as the difference between the height of the nodes, it should be either 0, plus 1 or minus 1. So nothing but it is a binary search tree in which the balance factor is defined in the difference by the difference between the height and the heights of the nodes. Okay, so the height of the nodes, the balance factor should be either 0, plus 1 or minus 1. So I have explained the definition. I know I didn't explain properly, but what is there in that? I will just say once again. So a binary search tree in which the balance factor is defined as the difference between the heights of the nodes. So there are multiple nodes, and according to the difference between the heights of those nodes, this balance factor is defined. So which can be either 0, minus 1 or plus 1. It will go to plus 2 and minus 2, but that should again be changed and reduced to 0, 0 itself. Okay, so this is the definition. If you want, just take a screenshot. Okay, so now they also asked in this thing like about AVL tree and that 4 notations. What is that 4 notations? So it's very simple. Okay, I'll just talk about that. So let us see. One notation is left, one is right, one is left right, and another is right left. Very simple, right? Even the problem, the way we solve is also that simple. Okay, so let us take an example. First, before starting this, let me just explain you how this balance factor is written. So suppose this is a node A. So the balance factor of this is 0. Okay, if a node is not having any subtree, the balance factor is 0. Suppose it has only left subtree B, the balance factor becomes 1, and this is 0. Why this is 0? Because this has no subtree. Suppose it has only right subtree B, then the balance factor is minus 1. This remains 0 because it has no children. So remember that if it is having right side, first it should have left node. If it is having both the nodes now, okay, suppose it has both the nodes. So this is 0, this is 0. This will also become 0, or you can simply say that as 1 also. Okay, but no, you cannot say that as 1, it will be 0 itself. Understood? Since it is balanced now, so the weight becomes 0. Okay, let me also give some example. This is A, there is a node B. So you can say that B is 0 because it has no children. So but this is 1 because there is one weight over this side. Now suppose B has another child C. So this becomes 0. This doesn't remain 0. Why? Because it has one thing. So balance has, it's off balance now. So one weight has come here. So for A, it won't remain A, it becomes 2 because there are 2 nodes on the left hand side. So the balance becomes 2 here. Okay. Similarly, if I do it like this, see, this will remain 0, but this 1 will become minus 1 like I said earlier, and this will remain 2 as it is. Okay, I hope you are understanding this, right? Why this is 2? Because it doesn't have any right subtree, it has both the left thing itself. Since both are left, it is what to say, 2 here. Suppose we had nodes like this. Okay, any nodes D and E. So this will be 0, this will be minus 1, this will become 0 now. Understood? Okay, let us take another example. A, B. So this will be minus 1, this will be 0. Why? Because it is in the right hand side. If it was left hand side, this will be plus 1. Suppose we have another node here C. So this is 0 now. This becomes minus 1 and this becomes minus 2. Similarly, if it is like this, this becomes plus 1, this is 0, but that's still minus 2. I hope you understood this. And now the balance search tree, it should be in the form in such a way that root node is greater than the left subtree and smaller than the right subtree. Suppose it here it is 1, 2, 3. You can see root node is greater than left side but lesser than right side. Let us take an example and show the left, right and left right, right left notation. So first you can create your own example here. Suppose this is a balanced search tree like this. So 3 2 1, what will be the balance factor? 2 1 0. So now this thing will get converted to, so now what I am doing, I will shift this node, I will do one right shift. So what will happen, 2 will go up, since it went to right shift, 3 node 3 went to right shift, node 3 becomes a right subtree of 2, and here it is 1. So now it's balanced. Okay, so this was the right shift, right notation, R notation, rotation, not notation, rotation. Okay, so now let us see another example for left rotation. Same example you can take, 3 2 1 0 minus 1 minus 2, don't forget and make mistake in this. So left rotation, so this goes like this, right? Now what this list become, 2 sorry, the numbers I took is wrong, 2 1 3, okay, and make it as 0 0 0. Make sure you don't make mistakes in examples. This is 1 2 3. Why? Because it should be balanced. So 2 should be greater than 1 and lesser than 3, like that. Root should be greater. Okay, now we have done with the left and right notation. Now let us go with left first and then right. Suppose we have a tree like this, like the share icon in most of the device. So let us assume, so this is 3, this is 1 and this is 2. So this is 0, this is minus 1 and this is 2. The what is that balance factor. So now what I have to do, it is left right notation. First left, so this 2 now I am sending here. Okay, then how it becomes, it's like this, it becomes like this now, 2, and this becomes like this, 1 0 1 2, and then right notation, 2 3 1 0 0 0. First it becomes like this, then it becomes like this. Okay, first like this, then like this. Are you understanding, students? Then let us go for right left notation, like this. Okay, so I can same way, here I will keep it 1, here I will keep 3, and here I will keep 2. So first right and then left. Right, so 2 will go there, it will become like this, 1 2 3. Oh, I forgot to mention, this is 0, this is 1, but this is minus 2. Now this is 0 minus 1 minus 2. Then left notation, so 2 1 3 all are 0. Okay, or we have done with these 4 notations. Yes, sometimes they will give a list of numbers. Okay, and then they will ask us to make a balanced search tree from the given list of numbers. So let us try. So 5 6 8 3 2 4 7. Okay, so now first I will take 5, first number is my root number. Then I will take 6. If I am adding, I will add 6 to the right hand side of 5. Why? Because 6 is greater than 5. So the balance factor, first I will write 5, the balance factor is 0. Okay, then it's changing 5 and here 6, it is 0 here but minus 1 here. Next number is 8, 5 6 8 0 minus 1 minus 2. So now what will happen, left shift. Okay, 6 5 8 0 0 0. Okay, these terms are done. Now 3 will get added. So 6 5 here 8 and 3 will get added here. So this is 0, this is 0, this is 1. Okay, so now this will become 1. Why? Because see here 2 are there, here only 1 is there, so 2 minus 1, that will become 1. Okay, I forgot to explain this kind of balance factor itself. This remains 1. Why? Because if this node was not there, it would be 2, but one node gets added, so balancing, so only one node is off balance, so one node will come. You try to understand with that kind of logic. Okay, so 3 is added now. It's already a kind of balanced right now. Okay, there is no changes. Now again 3 done, now 2 is added, so it becomes 6, 5, 3, 2, and only here it is 8. So now it is off balance, so whenever it becomes 2, okay, 0, 0, 1, 1, so now it is off balance. Now what I should do? Now don't go on do one right shift and make it look like this, that's not the right way. Okay, now whenever you go for this shift here, you should always make sure that the root node is greater, whatever the root node is, it's greater than the left side and smaller than right side. So now I will do one right shift. What I can do here is, see here, this thing is a right 5, I can send 3 here and get the 5 thing down. Okay, so it will become like 6, 3, 2, 5, and here 8. So now what happens? 0, 0, this becomes 0, this is also 0, and now this thing becomes 1. Why is it still becoming 1? Is because it has one extra level, right? Height of the node, difference between the height of the node, it's one extra here. Okay, both should be balanced. Next, so till here it's done. I'll add 4 again. Where this 4 come? 4 will come to the left of 5. Okay, let me try and fit it here. 6, 3, 2, 6, 3, 2, 5, and 4, and 8. So this will be 0, this becomes 1, this becomes 0, this becomes 2, minus 2, and this will become, okay, wait, 0, 1, 0, sorry, this won't become minus 2 because we have one left child, right? So this will be 1, minus 1 itself, only minus 1, it won't be plus 1, it will be minus 1, and this will be 2 because if I remove 8, 2 and 5 still there, right? So this is 2. Okay, so this thing again I can do some shift here. Okay, it became 2, right? If it is 2, I have to do something. So what I can do now, I can bring this 5 here and send this 6 and 8 towards the right. Okay, why? Because just got stuck in the middle, so I just recorded again. So I erase this part. Why? Because 4 comes here, right? So I did not have space, so this is 0, this is, it was 0, it will become 1, this was 0, it will become minus 1 because one off balance is there in the right subtree of this thing. So this becomes 2. Okay, now why? Because this is one level, another level, so 2 level down is 2. So now I have to do some shift. So now what I can do, I have to shift in such a, I cannot send this 3 here. Why? Because 3 here, I have 5 greater than 3, so left side it will become, it won't satisfy the condition. So what I can do, I can, to balance this in such a way, I can bring this 5 towards the root. So if I have to bring 5 towards the root, first I have to do a left shift. By doing left shift, then again I can bring 5 here. So 5, so when I do left shift, no, what will happen, 5 is like this, 3 and 2 will go like this, and this will be 4 will remain like this, I guess. Okay, then I can send this 5 again over there. Since I do shift, so what will happen, 3 will come in this place, 2 will come in this place. Okay, then 5 will go to the 6th place, and 6 will just push down, will be pushed down. 5, so here it is 3, 2, 4, 6, and 8. Okay, 0, 0, 0, this is also 0, this is minus 1, and this is 0. Why is it 0? It's because the height, the difference between height is satisfied, so the balance factor is 0, right? So okay, then 4 is done. Last 7 thing, if I add 7, 7 will come here. I can do one right shift and then left shift. So what will happen, 1 right, 7 comes here, 8 goes here. Okay, so actually here shift will change, right? So this is 0, this is 1, okay, and then this will become minus 2, and then this will become minus 1. Then I will do one right shift. So what will happen, my 7 will go here, 8 will come here, this thing won't be existing anymore, this is 4 not, and here 6 will come, okay. So 0 0, this is also 0, this becomes 0. So that's it, the balanced search tree. If they give some list how to make the balanced search tree also, okay, it's like this, then this thing, okay, one step, second step, third step, okay, that's it folks, nothing else is there or nothing else is required for this. So this was the way of doing this balance search tree. I don't think any further explanation is required. I try to do it in the so I have explained everything, definition, 4 rotations, and then how to make a list from this. Sometimes I will give a graph directly, this kind of not this kind of, this kind of graph maybe, and say they like make it balanced. So same left right notations will happen one by one, and then you can do it.